Welcome to the Deep Dive. If you're someone who loves getting up to speed on fascinating topics, well, today we're venturing right out to the very edge of our solar system.
That's right. We're talking about a really strange group of objects called sednoids.
Sednoids. Officially, they're trans-Neptunian detached objects, right?
Correct. And our goal today is pretty straightforward.
Yeah.
Understand why these objects are so unusual and, what they might be telling us about the solar system's hidden depths.
Okay, so let's get that definition clear. What makes an object a sednoid?
Well, there are a few key things. They're TNOs, yes, but they have these huge, really stretched out eccentric orbits.
Right, elongated.
Exactly. And crucially, their perihelion, that's their closest point to the sun, is incredibly distant.
How distant are we talking?
We're talking greater than 60 astronomical units, 60 AU.
Okay, and just for perspective, Neptune orbits at about 30 AU?
Precisely. So even at their closest approach, they're twice as far from the sun as Neptune is.
Wow. And that's why they're called detached objects, because Neptune can't really grab them.
That's the idea. Neptune's gravity is just too weak out there to significantly tug on them or change their paths much. They're kind of in their own league.
So some people call them inner Oort cloud objects, too. Is that the same thing?
Essentially, yes. It places them in that sort of transitional zone beyond the Kuiper belt, but maybe not quite the main distant Oort cloud. IOC objects is another term you'll hear.
Interesting. That isolation really makes you wonder. Okay, before we dive into the dynamics, let's quickly thank our sponsor.
Good idea.
This deep dive is brought to you by embersilk.com.
Right, so diving back in, how many of these sednoids do we actually know about?
Yeah, is it a whole swarm or just a few?
It's actually remarkably few. Currently, only 4 are confirmed.
That's it.
Just 4. There's Sedna, the first one discovered, which gave the group its name. Then 2012 VP113.
Okay.
Then one with a really evocative name, 541132, Lele Ekohonoa. And the most recent addition, 2023 KQ14.
4. Okay, here's where I get really curious. Why should we care so much about just 4, distant rocks? What's the mystery?
The mystery is entirely in their orbits. They simply don't fit.
Don't fit how?
Well, we can usually explain orbits by looking at gravitational nudges from the giant planets, Jupiter, Saturn, Neptune, Uranus, or even the gentle pull of the galaxy itself, the galactic tide.
Right.
But for these 4, none of that works. Their orbits can't be explained by any known forces within the solar system as we currently understand it.
So something else must have put them there.
It points that way. It's a major puzzle because think about how planets form accretion. Things clump together.
Right, you need relatively calm circular orbits for that.
Exactly. If they formed way out there, their orbits should have started out pretty circular. The fact that they're now so incredibly stretched out, so elliptical, suggests some kind of major disruption event happened early on.
A disruption. Okay, so what are the theories? What could have done that?
There are basically 3 leading ideas floating around. Hypothesis 1. Maybe a star passed close by, way back when the sun was still in its birth cluster, with lots of other newborn stars around.
And that star's gravity just sort of yanked them outwards.
It could have gravitationally lifted them into these higher, more eccentric orbits.
Yeah.
Okay, what's number 2?
Number 2 is related. Maybe they weren't just lifted. Maybe they were actually captured entirely from a passing star system.
Huh. Stolen from another star. Interesting. Yeah. And the third one, that's the Planet 9 one, right?
That's one that gets a lot of attention, yes. The idea that there's an undiscovered planet out there, something big, beyond the Kuiper belt, that's gravitationally sculpting these orbits.
A hidden planet.
Yeah.
How does the data support that idea specifically?
Well, this is where it gets really compelling, statistically speaking. The first 3 known sednoids, Sedna, VP113, and Lele Ekohonoa, share something unexpected.
What's that?
Their orientation in space. The direction their long elliptical orbits point, what we call the argument of perihelion, is clustered around 0 degrees.
Wait, they all point roughly the same way. Shouldn't that be random?
It absolutely should be. Over billions of years, the gravitational nudges from the giant planets we know about should have completely randomized those orientations. They should be pointing all over the place.
But they're not.
They're not. The odds of seeing that clustering just by chance are incredibly low. Vanishingly small, actually.
So the thinking is something must be keeping them aligned.
That's the inference. Something massive, unseen, could be gravitationally corralling them, keeping them sort of oscillating or librating around that specific alignment.
And that something is Planet 9.
It's the leading candidate explanation for that specific clustering, yes. The models suggest you'd need something like a A dimly lit super-Earth, maybe 5 to 10 times Earth's mass, orbiting way out, perhaps around 250 AU on average, to do the job.
It sounds speculative, basing a whole planet on just 3 or 4 data points.
It is speculative, absolutely.
Yeah.
But it's speculation driven by trying to explain this very odd, statistically unlikely observation. It's currently the simplest dynamical explanation we have for the clustering.
Which connects back to why Sedna is called a fossil record.
Precisely. These objects, because they're so detached and relatively undisturbed by Neptune now, might preserve information about the solar system's very earliest conditions. Conditions may be influenced by passing stars or, potentially, this unseen planet.
So finding more of them is crucial.
Immensely. Lele Ekohonoa's discovery helped us estimate the potential size of this population. It suggests there could be, maybe millions of these inner-orbit cloud objects larger than, say, 40 kilometers across.
Millions, wow. Potentially adding up to a lot of mass.
Potentially, yeah. Some estimates suggest the total mass could even rival Pluto's. Finding more helps us understand the sun's birth environment. How crowded was it with other stars back then?
So wrapping this up, what's the big takeaway for us? These few tiny distant objects are basically poking holes in our nice, tidy picture of the solar system.
That's a good way to put it. They highlight significant gaps in our understanding of how our planetary system formed and evolved. They prove the outer solar system is far from empty and might hold secrets we haven't even dreamed of yet.
It really shifts your perspective.
It does. And it leaves us with a really provocative thought, something for you to ponder. If the orbits of just 4 small distant rocks hint at a possible hidden super-Earth,
Yeah.
what other fundamental truths about our solar system's chaotic birth in its early days are still locked away out there in the darkness beyond Neptune? What other undiscovered populations are just waiting?